All right, guys, quick video today. Just a couple review topics that we want to make sure you have down because we're going to be using them a lot this year. The first thing we're talking about is simplifying algebraic expressions. You're going to have expressions in everything we do. Every day there's going to be expressions that we're using. Sometimes they will be part of an equation, but part of what we have to do is simplify the math in front of us to whether it's to solve a problem or just to make it look easier to deal with and a little bit less overwhelming. So, a couple of things to remember about simplifying an algebraic expression. You can only add and subtract things together that are what are called like terms. There's an official definition in here for you. But, for example, 3x cannot be added to 2y. I can write that side by side, but I can't actually combine those together. But 3x's and 2 more x's can add together to become 5x's. There's nothing wrong with that. But x's and y's don't go together. In the same sense, if I have 3x's plus 2y's minus 6xy's, those don't combine together because these ones have x's, these ones have y's, these ones have x's and y's. And when that's the case, I'm not allowed to add or subtract them together. That's different if I'm multiplying. If this said what's 3x multiplied by 2y, I can go ahead and do that because I'm not combining them, I'm multiplying them together. So the 2 and the 3 get multiplied and then I'm just left with 6xy. But be careful that you don't combine things together that have different variables coming after them. Simplest form. How do you know when you're in simplest form? That's when there are no more parentheses in the problem and there are no terms that could be combined. So everything is simplified, distributed, combined as much as you are able to. That is what we call simplest form. So you've got a couple examples that are already worked out for you on the paper. So if I want to simplify 8y plus 7y, both of these have y's, so the 8 and the 7 add together to become 15, and then you put the y after it. It shows you the technical math that you're doing when you combine like terms, but we're never going to show this step. We're never going to show you take the 8y and the 7y and you factor out y to get 8 plus 7 in a parenthesis and a y on the outside and then add them together. Nobody does that. We know that that's what we're doing, but we just shorthand it and we just take the 8 and the 7, add them together to get the 15 and then put the y on the back end of it, okay? Example number 2, you've got 2 parenthesis x plus 5 minus 3 parenthesis x minus 2. Now this one, you got to get rid of the parentheses by distributing. So remember that you take that 2, you multiply it by the x to get the 2 x's, and then you take the 2, multiply it by 5, and that becomes 10. But when you distribute the 3, don't forget that negative sign in front of the 3. That gets distributed with the 3. So you get negative 3 times x, which is negative 3x, and you get negative 3 times negative 2, which becomes positive 6. And then you look for things that can go together. The x's can go together. Those become 5x's. And the constants can go together. The 10 plus 6 becomes 16. Oh, it's a negative 3x. Oh, bad math, Mr. Reed. 2x's minus 3x's is a negative x. We need to slow down a little bit. Trying to get through the video too fast. Okay, simplify this last one. When there's a lot of different terms going on, I usually try to underline things in a way that put them together. The first thing I see is an xy. So anything else with an xy, I'm going to put one line underneath it. And then my next term has only a y with it. So anything with a y, just a y, I'm going to put 2 lines underneath it. And I'm left over with negative 2x, and it's all by itself. So I could put 3 lines if I want to. And then I just combine things together. The 1xy and the minus 3xy becomes minus 2xy. The 3y's and the 5y's, which are both positive, become plus 8y, and then the minus 2x is still just minus 2x. Okay, one thing I did want to show you that's not on your note sheet, you maybe want to add this on there. I've got this equation, or this expression, 62i plus 3e multiplied by 2 pi plus 4i minus 9ei plus 16 pi. In this case, the variables are actually values, right? We know that I, well, maybe not yet. Maybe you haven't learned about I. I is actually a number. E is also a number. Pi is also a number. But I don't want to turn them into numbers because then I'm going to get a bunch of ugly decimals. I want to leave them as e's and i's and pi's. But when I combine them with other things, I've got to follow all the same rules. This 3i, I'm going to distribute, first of all. So I've got 62, or 3e, sorry. I got 62i out in front. 3e multiplied by 2 pi. Well, 3 times 2 is 6. And e and pi are variables, kind of, but I don't multiply them together. So they're just ey, or e pi. Then I take 3e and multiply it by 4i. So 3 times 4 is 12. E times I is just e times I because I'm leaving them as letters right now. Then I've got a minus 9ei and a plus 16 pi. Now the only things that can go together are things that have the same variables coming after them. This one has only an I. Nothing else only has an I. This one has an e and a pi. Nothing else has an e and a pi. This one has an e and an I. So does this one. So those are going to be able to go together. And then my last number is 16 pi, and there's nothing that only has a pi. So for the most part, things don't combine except for those two values, or those two factors that have the e and the I combined there. So 62i plus 6e pi, 12 ei's minus 9 ei's, man, this is a tongue twister here, is 3 ei's, and then I'm left with 16 pi. And that's as simplified as it gets, unless you want to turn all of these things into decimals and start combining ugly decimals together. But that's not part of the lesson today. Go ahead, do the problems at the bottom. If you run into something you've never seen before, make sure you come ask about it, and I'll help you out there. But everything you see down there, you should have seen in a previous class. Just be careful about distributing negatives, and I think you'll be okay. All right, the other topic for today is solving linear equations. At the middle school, at the intermediate school, your teachers use the phrase, use railroad tracks a lot, right? When they would want you to solve an equation, they referenced railroad tracks, which what you were doing is, like this example A down here, 5x minus 1 equals 2x plus 6, or negative 2x plus 6. If I were to write that up here, 5x minus 1 equals negative 2x plus 6. To solve this equation, I would need to get the x by itself. And you would use a method that we referred to as railroad tracks to move things from one side to the other side until eventually you're left with x equals something. That's what a solution to an equation is. A solution to an equation is a value that when you plug it in for the variable, it makes the equation true. That's how you know it's a solution to the equation. If you plug in a number and it makes the equation false, then that is not a solution to the equation. So this first example wants you to plug in a couple of numbers to see if they are a solution to the equation. So the first thing it wants you to plug in is a 1. So if I've got, here's my equation written out first. They've already done this one for you. Everywhere you see an x, you're going to replace it with a 1, but you're going to do so in parentheses. You're going to make sure that you don't just put a 1 by itself and turn that 5 into a 5-1. You're going to put it in parentheses so your calculator knows to multiply. So after you substitute in the 1, You see what you get on the left, you see what you get on the right. If they're the same, you're good to go. So on the left, 5 times 1 is 5. 5 minus 1 is 4. On the right, negative 2 times 1 is negative 2. Negative 2 plus 6 is also 4. If you don't know how to do this arithmetic, you've got a calculator, and you learned last class how to put that into your calculator and solve. Now, if I plug in a negative 2, there's a good chance it's not going to work because I already found a number that worked. X equals 1 worked. Let's see if x equals negative 2 works. So I take the same equation to start with, but now everywhere that there was an x, I'm going to replace it with a negative 2. So everywhere I see an x, I'm going to replace it with a negative 2. But again, I'm going to be careful that I put it in parentheses. Then I can go ahead and type it into my calculator if I want. And on the left-hand side, when I put that in my calculator, I get negative 11. On the right-hand side, when I plug this in the calculator, I get 10. Well, negative 11 and 10 are not the same. So x equals negative 2 is not the solution to the equation. Okay, example number 2. We've got 2 more here. They've already done for us, and then I'm going to go ahead and show you a couple extra examples as well. In these ones, it's not giving you a solution to check. It wants you to find the solution. So it starts you off with 4x minus 3 equals 13. Your teacher in middle school would have said, okay, do railroad tracks. And anything you do on the left, you have to do on the right. So we're trying to get x alone. I'm trying to get this x by itself. So I've got to get rid of that minus 3. So they add 3 to both sides. You can see that right here and right here. And they end up with a 4x on the left because these cancel out. They end up with a 16 on the right. Now I've got to get rid of the 4 in front of x. So I divide by 4. But if I do it on the left, I have to do it on the right. 4x divided by 4 becomes x. 16 divided by 4 becomes 4. So x equals 4 is my solution to that one. Okay, over here on the right, part B, you've got 2 multiplied by y minus 8 equals y plus 6. I'm going to get rid of the parentheses before I start simplifying this one. So I take that 2 and I distribute. And I end up with 2 times y minus 16 equals y plus 6. This one has a y on the left and a y on the right, but I can use my same rules to get the y's on the same side. If I take this y and I minus it on the right-hand side, it goes away. But if I minus it on the right, I also have to, if I minus it on the right, I have to minus it on the left. So I get 2y's minus 1y, just ends up being 1y. And I've got minus 16, and that equals 6. So I'm trying to get rid of this minus 16. The opposite is to add 16. I've got to do that to both sides. So I add 16 here, add 16 here, and I end up with y equals 22. All right, this is a skill that is not going away. Guys, you need to know how to do these problems. They're not going away anytime soon. You're going to use them in this class. You're going to use them next year. If you go to college, you are going to be using them in college. It's just one of those things that comes up all the time. You got to make sure you've got it down pretty well. So 2 more examples I want you to add to your notes. So I've got 3 multiplied by x plus 15 minus 12 equals 24. I want to get x alone, so I'm going to do railroad tracks. I've got some options here. I can distribute the 3 if I wanted to. I could take this 3 times it and then combine like terms, or I can do things a little bit different than I did in the last problem. If I want to add 12 to both sides, I can do that because that minus 12 is all by itself. And I end up with 3 multiplied by x plus 15 equals, 36? Now, again, I could distribute. I could take 3 times it by x times it by 15. Or I've got 3 multiplied by this parenthesis. Well, the opposite of multiplying by 3 is dividing by 3. And that'll make that 3 go away. So if I divide 3 over here, I get 12. So I have x plus 15 equals 12. Now all I have to do is minus 15 from both sides. And I end up with x equals what? Negative 3. That's my solution. Okay, second example I want you to add. I've got 13m's plus 6 times 2m minus 4 equals 20m plus 1. So a lot more going on in this one. I think I'm going to distribute the 6 this time and kind of clean things up before I start trying to solve. So 13m is just floating out here by itself. 6 multiplied by 2m, that becomes 12m's. And then 6 multiplied by negative 4 becomes negative 24. And that equals 20m plus 1. Now, before I do my railroad track stuff, I've got 13m's and 12m's on this side. I also have 20m's on the right, but it's on the opposite side of the equal sign, so I can't combine those together like I do on the left. So 13m's plus 12m's is 25m's minus 24 equals 20m plus 1. Now my goal is to get m alone. So I do my railroad track thing. I'm going to add 24 to both sides. So over here I get 25m. Over here I get 20m plus 25 because the 1 plus 24 equals 25. Now let's minus these 20m's to get them over here with these m's. And they're positive on the right, so I have to minus them to make them go away, right? So then I end up with 5m equals 25. Last step is to divide by 5, and we get m equals 5. Okay, hopefully that was review. Most of you should have seen this before. If you're in Math 2 and you haven't seen this before, I'm not sure how you got here, but make sure you understand how to do those problems. Come and see me if you need help. There's practice problems at the bottom. If you run into things you've never seen before or things you're rusty on, these fractions down here, remember that whatever's on the bottom is getting divided. So the opposite of dividing is multiplication. That makes the stuff on the bottom go away pretty quick. If you need help, come and get it. Good luck.